Racing cars like Formula One cars are so elegantly designed. Have you ever wondered why? If yes, then welcome. This video is for you. In this video, we'll try to discuss about the aerodynamics of racing cars. Together with engines, tires, roads and drivers, vehicle aerodynamics is also gaining popularity in racing industry. Vehicle aerodynamics is a broad term comprising engine intake and cooling flow, internal ventilation, tire cooling and overall external flow. We, however, will only focus on the effects of external aerodynamics here. First, it is important to realize why the study of aerodynamics is important in motor racing industry. You might assume that the major premise of aerodynamics in racing industry is drag reduction, but it isn't. Of course, drag reduction is important, but aerodynamicists are mainly focused on applying the airflow to generate the downward force on the vehicle so that the vehicle remains glued to the ground and does not somersault while moving around the corner with high speed. Now let's understand how the downward force improves the cornering speed. The basic principle of friction explains the effect. Consider a car moving around a corner. Balancing the forces in the vertical direction, we find that the normal reaction N is equals to mass times acceleration due to gravity, and the frictional force Fx provides the necessary centripetal force to complete the turn. Since Fx is equal to coefficient of friction times the normal reaction, we get Fx equals to mu times mg. Now if we provide the downward force Fz to the vehicle, then the new normal reaction N prime becomes mg plus Fz. Hence, the frictional force in this case, Fx prime is equal to mu times N prime, and that is equal to mu times mg plus Fz. Clearly, we can see that Fx prime in equation 2 is greater than Fx in equation 1. Since this friction provides the necessary centripetal force to complete the turn, the vehicle can corner with greater speed when frictional force is greater. That is, in the second case, when we provided the downward force. Now, as we understand the importance of downward force in improving the tire traction, we now move forward to understanding how this downward force is generated in racing cars. The downward force is generated by the pressure difference between the upper part and the lower part of the vehicle. In case of racing cars, this pressure difference is generated by adding wings at the front and the rear part of the vehicle, or by using the vehicle's body itself. First, let's understand how these wings generate the downward force. Before that, let's talk about a phenomenon. When there are strong winds, we might have seen the instances of the house roofs being blown away. This is because inside the house the air is still and at high pressure, whereas the velocity of air is very high outside, creating a low pressure there. Force is experienced from a high pressure region to the low pressure region, that is from inside the house to the outside, which blows away the roof. Similar phenomenon occurs in the wings of racing cars. The wings are designed with inverted airfoil section. The air below the wings slips with greater velocity than the air above, meaning that the lower section is the low pressure region and the downward force is exerted from the high pressure region, that is the upper part. Describing the very same effect in terms of the Newton's third law, the wing pushes the airflow upwards, and the same upward flowing air provides equal and opposite downward reaction to the vehicle. Now let's see how the vehicle body itself generates the downward force. Racing cars are designed with low clearance between their underbody and ground. Since we know from the Venturi effect that air moves faster when passing through smaller cross section, air moves with greater speed below the vehicle, creating a low pressure region and hence producing the downward force. To make this process more efficient, some legit design features like diffuser, vortex generators and spoilers are used. The diffuser in the racing car further accelerates the flow of air under the car, helping to create a very low pressure region underneath, thereby increasing the downward force. This happens because the diffuser increases in volume along its length, creating a void that has to be filled by the air passing under the body. The Venturi effect accelerates the flow through the throat of the diffuser to create the desired low pressure. Vortex generators are simple add-ons to the existing car to increase the downforce. The vortices from the vortex generators help to protect from flow separation at the diffuser and also reduce the pressure along their trail, both contributing the efficiency of downward force. In this way, aerodynamics is one of the major premises in motor racing industry. However, Since it is a very highly competitive field, the results of advanced research are kept confidential. Despite this, the video pretty much explains the basic idea of developing the efficient downward force through the study of aerodynamics in motor racing industry. Well, that's all for today. Hope you enjoyed. Thank you for watching.